Check one. Check one. Right. Good evening, everybody. Back again with our MCQ night session, right? We were doing on 2021 O-level paper. 20 questions are done. Today we have to start with 21 to 30, which means today we are hitting our 150 question. Before we start, confirm me from your end. Can you hear me properly and see the board clearly? Just put a thumbs up. Yes. Yes. Hari. Right. Today I went through the paper. Today is the day where we have some deep sections to discuss. Deep can we here? This part of the question. Every question has something to think on. Every question has something to think on. Every question has something to think on. Such a section is there. So I'll go in the normal order. Right. I'll go in the normal order. I'll go in the normal order. Question number 21 to question number 21 to 30 of 2021 O-level paper. I'll go in the normal order. Right. Question number 21. This is a question that we discussed in our seminar as well. Physics seminar. A few ways of connecting four resistors of equal magnitude are shown below. Four resistors, all four equal in magnitude. Of them, which one has the lowest equivalent resistance? Which one has the lowest equivalent resistance? Lowest equivalent resistance. Onna listen, shortcut. In resistor combination, lowest resistance is achieved when you connect the resistors in parallel. Keep that in mind. In resistor combination, lowest resistance is achieved. Lowest resistance is achieved. Lowest resistance, lowest equivalent resistance. Lowest equivalent resistance is achieved in what connection? Parallel connection. In parallel connection. Keep that in mind. Parallel connection, you achieve the lowest equivalent resistance. Ehenam, tell me, what connection gives us the highest equivalent resistance? Highest equivalent resistance, just guess and tell me. Lowest is parallel connection. Highest should be. Series connection. Series connection. Right? As much as you connect the resistors in parallel, as much as you can reduce the resistance. As much as you connect the resistors in series, as much as you can increase the resistance. Keep that shortcut in mind. So one shot, tell me what's the answer. They're asking lowest resistance, neither. They're asking lowest resistance. Series wrong. Here, two in parallel, the others are series wrong. Here 3 in parallel, 1 in series, no. Here all 4 in parallel, all 4 in parallel, lowest resistance. So keep that shortcut in mind. The more you connect the resistors in parallel, the more you can reduce the equivalent resistance. The more you connect the resistors in parallel, the more you can reduce the equivalent resistance. Keep that point in mind. Answer is answer 4. One shot, you can tell the answer. Question 22. Consider the following organs. A, skin. B, kidney. C, pancreas. Of these, those that contribute to maintain homeostasis of the body, those who contribute to maintain the homeostasis of the body. What is homeostasis means? Maintaining a constant internal environment. Maintaining a constant internal environment. Your internal environment consists of the tissue fluid, lymph. That internal environment's factors should be maintained constant. Then only your cell functions will take place properly. So maintaining a constant internal environment is homeostasis. Maintaining a constant internal environment is homeostasis. Maintaining a constant internal environment. Constant internal environment is homeostasis. So in homeostasis, what are the conditions in the internal environment you try to maintain constant? What are the conditions in internal environment you try to maintain constant? Three conditions, three factors you try to maintain constant. One, your blood glucose level. Two, your body temperature. Three, water balance. One, your blood glucose level. Two, your body temperature. Three, water balance. These are the three factors you try to maintain constant in your internal environment. What are they asking? Consider the following organs: skin, kidney, pancreas. Of these, those that contribute to maintain homeostasis. Skin, yes, skin will help us to maintain our body temperature. Skin helps to maintain the temperature. Why? When it is very hot, you start sweating. When it is cold, your sweating rate will decrease. Your sweat will decrease. You get goosebumps. Right? Those things are done. Blood flow to the skin is reduced. So skin help us to maintain our body temperature. Kidneys help us to balance what? Kidneys help us to balance our water level. Pancreas, is there any connection? Is there any connection for pancreas and homeostasis? Just because I am asking the question in a negative modulation doesn't mean your answer is always no. Pancreas has a connection. Pancreas only secretes insulin and glucagon hormone. Pancreas only secretes insulin and glucagon hormone. Actually, inside pancreas, you have islets of Langerhans. Inside islets of Langerhans, we have alpha and beta cells. Beta cells secrete insulin, alpha cells secrete glucagon. Insulin convert glucose to glycogen. Glucagon converts glycogen to glucose. Basically, insulin and glucagon will help us to maintain our glucose level, which means pancreas help us to maintain our glucose level. Keep that in mind. If you want, I'll write it on that note where I wrote. Glucose level is maintained by the involvement of pancreas, insulin and glucagon. I'll write that also, Sanki. It secretes insulin and glucagon. Body temperature, yes, skin plays a major role to maintain our body temperature. Water balance, yes, kidney plays a major role to maintain our water balance. For water balance, what's the hormone involved? There's a hormone involved in water balance. What's the hormone? Now, glucose, it's insulin and glucagon. Water balance? Antidiuresis hormone, short form ADH. Antidiuresis hormone. In short form, you call it ADH. On a simple short note is given, glucose level is maintained with the involvement of insulin and glucagon secreted by pancreas. Body temperature is maintained by skin. Yes. Water balance is maintained by antidiuresis hormone. It's not secreted by kidney. Don't think ADH is secreted by kidney. Okata, I will write and keep. Who can remember what secretes ADH? What secretes ADH? Our pituitary gland secreted by pituitary. It is secreted by pituitary gland. And it comes and acts on kidney. Secreted by pituitary and comes and acts in kidney. Keep that in mind. If you want, take a screenshot and keep. The screenshot, see that you're later right. I'm asking you to take screenshot because I need to manage the time. Right. So there, skin will also help, kidney will also help, pancreas will also help. All three will help. Answer is answer 4. A, B, C, all. Okay. Next one. This one also we discussed in seminar. Our first seminar. The graphs, not seminar, not seminar, in a rapid revision session. Not seminar, rapid revision session we discussed. Graph P and Q respectively indicate how the body temperature of two organisms P and Q varies with the temperature of the environment. Organism P and Q respectively. Analyze the graph. Now, some fellows are more scared when they see graphs. Graph question Q, they leave the question and do something else. Nothing big. There is a x-axis. X-axis here is the environmental temperature. There is a y-axis. Y-axis is the body temperature. How the temperature is varying. Look at organism P. Look at organism P. Look at organism P. Environmental temperature is increasing, but is the body temperature increasing? Is the body temperature increasing? Is the body temperature going up? Is it going down? No. Body temperature is constant. Whatever the environmental temperature is, body temperature is constant. Body temperature constant. Now, warm-blooded, the cold-blooded, the warm-blooded. Only 2 phylums are warm-blooded. No. Only 2 phylums are warm-blooded. No. What are the 2 phylums that are warm-blooded? Aves and Mammalia. Keep that in mind. Aves and Mammalia. Only 2 phylums are warm-blooded. Aves and Mammalia. Only Aves and Mammalia are warm-blooded. So this is warm-blooded. Body temperature is not changing. Look at Q. Environmental temperature increasing, body temperature also increasing. Environment temperature increasing, body temperature increasing. Now what bladder? Cold bladder. Cold bladder. That is cold bladder. So other than aves and mammals, all the others are cold bladder. Other than aves and mammals, all the others are cold bladder. So here they are asking organism P and Q respectively. P should be either a ave or a mammal. Q should be anything else, right? We'll analyze. First on ox and bat. Ox and bat. That is mammal. Second one cannot be mammal. Mammal first they are asking P, then they are asking Q. Second one cannot be a mammal. Then that is wrong. Fowl and tortoise. Fowl and tortoise. Hari need. Fowl is a bird, ave. Tortoise is a reptile. Fowl is a bird, ave. Tortoise is a reptile. This is correct. Elephant and duck. Elephant is a mammal. Duck is a ave. Both are same. Elephant is a mammal. Duck is a ave. I think both are warm-blooded. That is also wrong. Fourth one, frog and tilapia. Frog is viscous, cold-blooded. Tilapia, sorry, frog viscous, right? Frog is amphibian, cold-blooded. Tilapia is a viscous, again cold-blooded, wrong. So answer is answer 2, fowl and tortoise. This is a ave, this is a reptile. Okay. #24. In which order does the brightness of the bulb decrease in the circuit ABC? ABC, in which order brightness decreases? Decreases, right? How do you analyze? A and B, easy to analyze. To understand this, you should understand about short circuiting. Again, something that we did in rapid revision. You should understand about short circuiting. That is question number, what's the question number? 24, no? Question number 24. You should know about short circuiting. Isn't it? On a lamai, you have a circuit. Let's take a bulb is there. Now a certain amount of current flows through the bulb. Bulb will illuminate. Now let's take, you take a wire, connect it between these 2 points. When you connect a wire like this, now you call it short circuiting. You have short circuited this circuit. You have just connected the wire. That wire doesn't have any device. So it's just a wire connecting these 2 points. Now what will happen? Let's take a certain amount of current comes. Let's take 10 amperes of current comes. That 10 ampere comes there. That 10 ampere comes there. Now there is a junction. Usually at a junction, current divides. Now look at the division. If current goes to this route, there is a device, there is a bulb. If current goes in this route, there is no any devices, free route. This is free route. Here there is a device. Device is considered as a resistor. Keep that in mind. In current electricity, devices, electrical devices are resistors. It's a blockage for the path. So in this path, there is a blockage. There is a bulb. There is a blockage there. There is a block there. Now you all tell me, let's say you are going on a vehicle. You are at a junction point. There is a free route. There is a block route. Which route you will select? Which route you will select? Free route, the block route. The boys don't answer. Which route you will select? Free route. Neither. Here also same. Most of the current will go through the free route. I won't tell all the 10 ampere will go through free route, all the 10 ampere, but most of the current, maybe 9.8 amperes wage free route. Only about 0.2 amperes wage goes in the block route. This is short circuit. So when you short circuit a circuit, most of the current will go through that short circuited route. Only a minute current will go through the other route. Keep that in mind. Ehang, what happens to the brightness of the bulb when you short circuit it? Decrease, neither. Almost it get off. Almost it get off. Almost off. Why? Most of the current will go through the short circuited route. Most of them will go through the short circuited route. Hurry. Now analyze that question. In which order does the brightness of the bulb decrease in the circuit A, B, C? C is short circuiting, which means it will have the lowest current in the bulb. It will have the lowest brightness. No doubt there, C is lowest brightness. No doubt there, C is lowest brightness. C will have the lowest brightness. Lowest brightness. Why? Short circuit. Now the fight is between A and B. B has a resistor. What will resistor do to the current flow? It will allow the same current, it will decrease the current, or resistor will decrease the current. Here no resistor. Again, all the current will go through the bulb. Here there is a resistor. There I have a resistor. Here I have a resistor. There I don't have a resistor, which means here I will have the highest current flow. Here I will have the highest current flow. Here I will have the highest. Here somewhere average current flow, there will be the lowest. Average current flow, there will be the lowest. Highest, why? No any blockage, no. Only bulb is there. Here, a resistor is there. A small block is there. Here, we have created a separate path in which most of the current can go. Sorry, wait. So only minute current will go through the bulb. So again look. Here, all the current will go through the bulb, highest brightness. Here, resistor will reduce the current, little less brightness. Here, almost all the current will go through the short circuited route. Very less current will go through the bulb, lowest brightness. So they are asking the order in which brightness of the bulb decrease. Decrease. Highest is A, lowest is B, very lowest is C. Answer is answer 1. Got it? Got it? Right. Perfect. Question 25. Some information regarding an element are as follows. Has several allotropic formula. When you hear the word allotrope, only 2 answers should come into your mind. When you hear the word allotrope, that is question 26, no? No, 25. When you hear the word allotrope, only 2 options should come into your mind. One is carbon, that should come into your mind first. The other is sulfur. When you hear the word allotrope, only 2 options, carbon and sulfur. So they are telling has allotropes. Has several allotropic forms, either carbon or sulfur. One allotropic form conduct electricity. Now only one answer, only one can conduct electricity here. No? Who is that? Out of carbon and sulfur, only one can conduct electricity. No? Who is that? Carbon graphite. That is answer 1. That's answer 1. 26. Some functions of human brain are given below. Reception of senses, maintaining the balance of the body, controlling the rate of heartbeat. I think I already talked about the functions of our parts of the brain. Some functions of the human brain are given. Reception of senses. Reception of senses are done by cerebrum. Reception of senses are done by cerebrum. This is done by cerebrum. Maintaining the balance of the body. Body balance is done by cerebellum. Body balance is done by cerebellum. All your balancing part, movement part, that is cerebellum. Balancing part, movement part, all are cerebellum. Rate of heartbeat, rate of respiration, reflex action, those are done by your medulla oblongata. So the reception of senses part, thinking part, intelligence part, memory, those are cerebrum. Body balance, body balance, movements, those are cerebellum. Rate of heartbeat, rate of respiration, reflex action, those are medulla oblongata. Now what's the question asking? Of the above, cerebellum control, maintaining the balance of the body, that is answer B. Only B. Answer 2. Hurry. Question 27. Consider the following statement. Statement type question. Can you remember we did a question like this already? Now I told you these types of questions are now coming up. They give two statement and ask whether One is true, one is false, one is true, the other is true. That kind of statement type question. Consider the following statement. A, rate of reaction increases when the temperature increases. Rate of reaction depends on 4 factors. What are the 4 factors? Number 1, surface area of the reactant. 2, temperature of the reaction. 3, concentration. Specifically, if it is gaseous reactant, pressure. Finally, presence of catalyst. Presence of catalyst. When any one of these increases, rate of reaction will increase. When any one of these increases, rate of reaction increases. Surface area, temperature, concentration, catalyst. When any one of these increases. Now, catalyst, we don't tell increases. When catalyst is put, or when any one of these increases, rate of reaction will increase. Alright. So statement is telling rate of reaction increases when the temperature increases. That is true. B part, kinetic energy of reactant particle increases when the temperature increases. Can you all remember under heat lesson you all learned the definition of temperature? Definition of temperature. Your part 2 book, first lesson, first page, at the end there is a highlighted part. Check that. Grade 11, part 2 book, first lesson, first page, at the end there is a highlighted part. It gives us the definition of temperature. How temperature is defined? Temperature is the measure of mean kinetic energy of particles. What is temperature? Temperature is the measure of mean kinetic energy of the particles. Is that measure of the mean kinetic energy of the particle? That means, what is kinetic energy means? Movement. Temperature is the measure of the movement of the particle. Temperature is the measure of the mean kinetic energy of the particle. Simply, the temperature is the measure of the kinetic energy of the particle. If the temperature increases, kinetic energy of particles will also increase. If the temperature decrease, kinetic energy of the particles will decrease. Best example, I'll repeatedly tell this. What's the best example? Think about making tea. Initially, you keep the mutti on the cooker and fill it with water. Think about the initial water in the mutti. Initial water is very calm and quiet. But after some time, when you heat it, you increase the temperature. You all tell me, will the water be calm and quiet, or it will dance up and down? It will be calm and quiet, or it will dance up and down? When you increase the temperature, it will be calm and quiet or dance, unhurry. It will be dancing up and down. Why it is dancing up and down? Because water particles inside it are in a random motion, here and there. Why the water particles at a random motion? That is because when you increase the temperature, kinetic energy of the particles increases. Kinetic energy of the particle increases. You all tell me, when kinetic energy of the particle increases, can the particles be calm and quiet? No. They will be randomly moving here and there. So remember, when temperature increase, kinetic energy increase. When temperature decrease, kinetic energy decrease. Now connect it with rate of reaction. What did I tell? When temperature increases, rate of reaction increases. That I already told. Now what did I tell? When temperature increases, kinetic energy of the particles will increase. Now connect them. When temperature increase, kinetic energy of particle increase. As the kinetic energy of particles are increasing only, rate of reaction is increasing. Hari my practically thing. When temperature increases, kinetic energy of particles increases. Particles are moving here and there randomly now. When they are moving here and there randomly, they will collide faster. When they collide faster, reaction speed will increase. Because the more the collision happens between the reactant particle, the more fast the reaction will proceed. The more the collisions happen between the reactant particles, the more the reaction speed will increase. So when the kinetic energy increases, reaction particles collisions will increase. When the collisions increases, rate of reaction will increase. Again, look at that last part. When temperature increases, kinetic energy of the particle increases. When kinetic energy of the particles increases, particles move randomly here and there. Their motion increases. When their motion increases, their collision increases. When collision increases, their speed of reaction increases, rate of reaction increases. Keep that point in mind. For it? So that is what is told there. The kinetic energy of reactant particle increase when temperature increase. Temperature increase, kinetic energy increases. A is true, B is true, both are true, answer is answer 1. Question 29. Which of the following phenomenon cannot be explained by Archimedes principle? Now, third or fourth time we are coming across Archimedes principle. Which of the following cannot be explained by Archimedes principle? A ship cruising in sea, sinking more when entering a river. Usually when ship transfers from the sea to the river, it sinks more. Why it sinks more? Upthrust increase the decrease. Practically think, why something sink more? Why something goes down? Upthrust increase the decrease. The decrease ne? Who talks about upthrust? Who talks about upthrust? Mama Nevi. I am not talking about upthrust. Who talked about upthrust? Archimedes. So this can be explained by Archimedes principle. This can be explained by Archimedes principle. They ask him which cannot be explained. Second one. A balloon filled with helium gas moving upward through air. Balloon, air. Archimedes didn't talk about air. No, he was talking about air. Look at Archimedes principle. He is talking about fluids. What did Archimedes tell in his principle? He didn't tell about liquids. He was talking about fluids. Fluids means what? Both liquids and gases. Keep that in mind. Most of the students think fluids means only liquids. Wrong. Fluid kiyanne both liquids and gas. For both we call fluids. Erase that mindset in your mind thinking that fluid kiyanne liquid කියලා නෑ. ඉතින් if liquid is liquid, why we need to call it fluid? Just think. Liquid is called liquid now, why we should call it a fluid? Fluid is a common word we give for both liquids and gases. So even Archimedes principle is valid for gases. Harini, think about helium balloon going up. Why the helium balloon is going up? Upthrust is more, the upthrust is less. Upthrust is more. Who is talking about upthrust? Archimedes. So they're asking which one cannot be explained. Third one. Floating. With that we have the answer. Floating of sunk orange seed in a glass of orange juice when dissolved sugar. Usually, orange seeds which are at the bottom, when you are making, let's take orange drink, orange seeds which are at the bottom, when you dissolve sugar there, those seeds will come up. Why when you dissolve sugar, those seeds come up? That's because when you dissolve sugar lamai, sugar will increase the density of the water there. Once then the density of water increases, the seeds will come up. Why? Seeds upthrust increase the decrease. Upthrust increase. Who is talking about upthrust? Archimedes. That's also wrong. Fourth one. Lifting a large mass by hydraulic jack by applying a small force. Lamai, hydraulic jack, Archimedes didn't talk. Archimedes can't talk about everything. No? He didn't talk about hydraulic jack. Hydraulic jack, Pascal was discussing about it. Right? There's a principle called Pascal's principle. That name is not there in our textbook. What is there in our textbook is principle of transmission of pressure through liquids. Right? That's the heading given. Recently in rapid revision, we were talking about it. Principle of transmission of pressure through liquids. That's the heading given, but actually that principle is Pascal's principle. Pascal was talking about transmission of pressure through liquid. Remember, hydraulic jack works based on Pascal's principle. This is based on Pascal's principle. Pascal comes into play. All the other places, yes, Archimedes comes into play. Here it's Pascal. So they're asking which cannot be explained. Answer is answer 4. You can't explain that. Question 29. That's a good question. Eh? Question 29. Somewhere you have to think. Practically, you have to think. Diagram shows a cross section of a cylindrical concrete ring kept on a flight of steps. Indicated as A, B, C, D are 4 points at which force can be applied by a man to roll it to the upper level. What is the point at which force can be applied on the cylinder in a suitable direction to roll it up with lowest force? You should roll it with lowest force. From where you can roll it with lowest force? From where you can roll it with lowest force? Maybe with practical knowledge, you can tell the answer. Scientifically, if I tell the answer, this is the answer. Around this point only, the concrete ring should roll. Around this point. Around that point, it has to roll and go up. Around that point, it has to roll and go up. Which means this is the pivot point. That is the pivot point. If you are applying the smallest force, your smallest force should be perpendicular to the pivot point. Your smallest force comes when it is perpendicular to the pivot point. Which means where you apply your force? At A. A, you can roll it with the lowest force. Some people will argue, sir, here I will have a reaction force. That reaction part is not there in your syllabus. There we have a reaction force. So against that reaction, if we give our force, won't it roll? Yes, that is also correct. There I will have a reaction force that direction. Against that, if I give a force, won't it roll? Yes, lowest force. Guaranteed D no, guaranteed C no. That year they gave marks for both A and B. Both A and B. Right. So you can get marks for both A and B. That's a practical question which you need to think and answer. A is correct, even B is correct. Last question. When thin iron wool is heated, it instantly burns. When an iron wool is heated, it is burning, it seems. Anything. Usually iron won't burn. But when it is made into iron wool, it burns. Why Lama it burns when it is made into iron wool? Its surface area increases. All the iron get exposed out. Surface area increases when you make the iron into a wool. But though an iron nail is heated till red hot, it does not undergo a considerable change. Anything. Wool will catch fire and burn, not the iron nail. Why? Here the surface area is less. Here surface area is more. All the internal parts are exposed out. Here internal parts are not exposed out. Not exposed out. Here inside everything is exposed out. Just imagine you take the iron nail and make it into a wool. Right? You scrap everything and you make it into a wool. All inside will be exposed out. Then surface area increases. Nail, usually nail surface area less compared to the iron wool. What conclusion can be drawn from these observations? Iron wool act as a catalyst. Iron wool and iron nail undergo reaction different to each other. No, both their reaction should be same. Both are Fe. Both are Fe. Both their reaction should be same. The composition of iron wool and iron nail is different from each other. No, internal composition is same. Last one. Rate of reaction depends on the physical nature of the reactant. Hurry anything. Surface area is what? Physical nature. So iron wool surface area high, iron nail surface area low. They have two different physical nature. Both are iron. But here the physical nature is different. As the physical nature is different, what we are talking under physical nature? Surface area. As the surface area is different, rate of reaction is different. I already talked about it. When rate of reaction is different, the rate of combustion will be different. So rate of reaction depends on the physical nature of the reactant. Yes, that's your answer. Okay. Right? That completes us 150 MCQs. That completes us 150 MCQs, right? And with tomorrow, we're finishing 2021 O-level paper as well. Good paper. So many things we had to discuss, right? About your work plan. January 5th is also over. January 6th is starting. You think to yourself and see the workload you're doing is enough for your target result or it is not enough. Regret is for you. If you keep on wasting your time unnecessarily, that keeps on adding up and finally your result will only go down. You should put in your mind and keep every time you waste your time, your result is turning in the negative way downwards. Keep that in mind and work. Unnecessarily don't use phone. Unnecessarily don't sit and start thinking about what you will do after you get your result. For that, first you should get your result. Daydreaming problem, more a problem. You have to control your mind and tell yourself, oh no, this is not the time for me to daydream. If I daydream, I will keep on wasting time and I will fall down some more. Tell to yourself and get up and start working again. Final about, I would tell about 35 days. Final about 35 days. Put your maximum into this. Final 35 days. Don't give it up. You were running onto this. You were catching on to this. Not to give it up at the end, but to finish off in the best way you can. Work on to this. Catch it and work on. Run with the others. Finish it in the best way you can. Hurry. I'll finish off with that. Tomorrow we have the night session as usual. Tomorrow is a very hectic day. There's a seminar I'll travel to Matale early morning, leaving at 3 o'clock. Again, evening, I have class at Colombo, and night, your class. However, I'll meet you all tomorrow night. Thank you and God bless you. Bye. Good night.